Hi, so I hope you hear me. Okay, so basically, based on what Julia showed you, we can do this very similar and same things for plotting and visualization in Python. And there's a lot of libraries that you can explore. And here we show some of the most popular ones. So we have Matplotlib and Seaborn, Plot9 and Plotly. So Matplotlib, and Seaborn probably you've already heard of them. So Matplotlib has been around since 2003. So it's basically, it's a very popular library for visualization in Python. It's a very prominent tool, and it also has a comprehensive range of types of graphs that you can generate. So you have scatter plots, histograms, box plots, so you name it. And we can think of it as kind of like analogous to the base plotting in R. So yeah, so here you can see the for Matplotlib on the right. First, the basic the anatomy of a figure. So the figure is basically the whole figure, or it's like a box or top level container that it's like a canvas that can contain multiple child axes. So each axis here you can see there is basically its own plot. And you can also see here shown all the different elements or components of the plot. So these are different artist objects. So you have, for example, the titles, the figure legends, so color bars, and so on. So yeah, and on the left, you can see an example of how to generate also a scatter plot of the same Palmer penguins data set. So you first what's called instantiate your figure and axis, and then here the second line you can basically specify the colors that you can use, but actually you can also just use the built-in color palettes that are also available in Matplotlib. And here we generate a scatter plot for each species. So here of course there's other ways to do it. Here they use a for loop. So you can then subset for each species and then generate your scatter plot. And you can specify the color, the corresponding color, and set the alpha and also the label. So after that, you can then kind of customize them. You can add your label for the x-axis and y-axis, title, and also adjust your font sizes. And then later you add your legend, and then you grid, and then you do the plt.show. So here we provide the link to cheat sheet, so you can go through them easily, and for the Matplotlib. Yeah, so basically, what would be the pros and cons of using Matplotlib? So as we said, Matplotlib is very popular, so you have already a lot of users. It's a classic visualization tool, and it can create a range of plot types and detailed visualizations. So in the beginning, if you're not a experienced user, there might be a learning curve, but it's good to learn this because there's also a lot of other packages that can build on and extend Matplotlib. And also, as you've seen, the code can be quite a lot depending on the task. So it can require a lot of code, lines of code, and there's also no concept of faceting. And yeah, so it's mostly for the two-dimensional data analysis. You can also do like three-dimensional or animations, but it's typically used for two-dimensional data analysis. Yeah. So next is Seaborn. So this is a more high-level, provides a more high-level interface, and it's built on Matplotlib. So it's in contrast to Matplotlib, it's more data set oriented. So it integrates very well with your pandas data frames, and it might be useful to distinguish between figure level functions and axis level functions. So figure level functions, it basically creates automatically in a single step. your whole figure, as you've seen in the anatomy of a figure, and then as well as some relevant axes in one single step. So it operates more on the level of data sets. So it basically combines one or more of these axis level functions. So you have scatterplot, boxplot, and so on, more specific ones with an object that manages the overall layout. So you can also do basically create multiple plots in one figure level function. So here, Seaborn divides it into relational, distributional, and categorical figure level functions. So for rel plot, it's you have scatter plot and line plot. So it's basically it's useful for examining the relationship between two variables or two columns in your data set. And this plot for distributional plots, so you can examine the distribution of a variable. And you also have your categorical plot, which includes these strict plots, swarm plots, box plots, and so on, which we will examine in more detail later. Yeah, so let's just have an example of figure level functions. So here we can generate a scatter plot using the relational figure level function. We specify the data set that we're going to use, and then we're going to specify which will be used for the so for the X and Y axes. And then we can also easily specify the color. So basically we set the U parameter, we color the data by species. So we have these 3 different colors here. And here in this particular code also, we also specify the style. So as you can see, for example, the Adelie species are in points, and the others have, you see different types of markers. Yeah. So, sorry, can you go? Yeah. So, and for the next one, so yeah, it's basically you can also just quickly do your linear model, regression model plot along with some data points. Yeah. Yeah, so just more examples. Here we have a type of categorical plots, and you can specify, you can change the the data representation by specifying the kind parameter. So here, for example, on the left, you see a swarm plot where you can see the data points, and whereas if you specify violin in the kind parameter, then you would see violin plots across your different categories, or here in this case, your species. Yeah, so Seaborn, you can also do faceting. Here you can do it in Seaborn by specifying the call parameter. So you do the faceting across the species, for example. So it's quite easy. Yeah. And just to give an example, for an axis level function, so here you basically create your figure in axes, and then you can manually add to this your box plot and scatter plot. So axis level functions are better when you want more customization. So you can manually add your different types of plots. And here, as you notice, we use more as a function called box plot and scatter plot, as opposed to, say, cat plot or rel plot. Yeah, so here, just to quickly illustrate, you can do Seaborn is it's compatible with Matplotlib, so we can for better customization, you might at some point need to also use Matplotlib. So Seaborn is for mostly designed to create a simple or to have like less code for quick tasks. But of course, at some point, you might need to have more customized plots. So you can also use Matplotlib functions on top. So here, for example, you can also in this particular example, we added like another dimension on the plot. So for example, here in the sizes of the data points, we we specify the body mass. So the size of the points will be greater for those with higher body mass, as you can see. So you can also add a different dimension using Seaborn, but you can also add, like, say, adjust the legend using Matplotlib. Yeah. So what are the pros and cons? So yeah, so as we've seen, Seaborn can offer different functions and plot types, and it integrates well with their pandas data frames. And for simpler or faster tasks, you can quickly generate nice visualizations. But if it has limited flexibility, so you might need to add more code using Matplotlib. And also it's mostly typically used for two-dimensional analysis. Yeah, so now we move on to the next library that is available for Python, and it's basically it's PlotN. So it's basically an alternative, a Python alternative to ggplot2. So it has a very similar syntax, and it also uses the grammar of graphics approach. So it can also do similar plots as same types of charts as Seaborn, basically. So yeah, so here in this example, we generate these plots with faceting. And here, as you can see, it's very similar to what Julia showed earlier, but in this case, we add these parentheses on top of these so that it's more compatible with Python. And so for Python, for experienced Python users, it might be not be intuitive, since it's more like an R syntax. But for our users that might want to, it might be comfortable for our users, say, that want to transition to Python. So we can see more in the next example. So as you can see, we compare here what a ggplot code looks like versus the PlotN code, and they're very similar. But what we could see that is different is, for example, in ggplot, you specify the species, but without parentheses, but in PlotN, you add the parentheses. And as I've mentioned, you also add parentheses, sorry, the quotation marks, and also the parentheses. And also, if you notice, the color might be different. So here in the ggplot, you see purple has a different purple from the PlotN. So they can be different. So you might want to watch out for that. But basically, it is a ggplot for Python. And you also use the plus operator basically to build your plots. Yeah, sorry. Yeah. So there's also a lot of available colors in Python. You can use also hexadecimal color codes. There's also built-in named colors, as shown here, for example. And you can use, there's also a lot of available color maps. So you can also use from Palatable and Color Brewer for Python. So you can check out these links that we provide if you want to if you want to generate your plot with these more specific colors. And you can also, of course, create your custom palettes. Yeah. So as with R, of course, they would also offer some of these sequential color maps, also diverging color maps, qualitative color maps, and also perceptually uniform sequential color maps. So there's a wide range of available and built-in color maps. And again, we link to these. You can check out these links to see them in more detail. Yeah. So now there is also an available a library for Python that is specialized for visualizations that are interactive. So you also have Plotly for Python. So it's good for web visualizations and interactions, and yeah, so that you can explore new data sets. So you can, yeah, so you can go to the next. So here is just an example for Python. So basically, there's two modes. You can use the Plotly Express for quick plots. These are the more high-level functions, and basically, the idea is that you can generate these interactive plots with just a single line of code. Well, yeah, here it's free, but here you can also, update your layout. Say set certain width or height, for example. But here you can basically do so import Plotly Express as px and then do the px.scatter, and then you specify your data, x and y, and also the color. So it also has these cool interactive features. You can hover, you can pan, you can zoom, and so on, as Julia already demonstrated. And so you can also check out the links that we provided for some tutorials. So so here, just to demonstrate that there's also a wide range of different plot types. And so there's also faceting. So in this case, for the scatter plot on the left, you simply specify the facet column. So here we specified the continent to across faceting. We do faceting across the continent. And yeah, so you can check out again the links that we provide for more detailed ones and their documentation. So they also have Plotly graph objects. So this is more, it gives you more fine-grained control over your visualizations. But as you can see, if it might need a lot more lines of code, and so we can think of it like Plotly Express is to Seaborn and Plotly Graph Objects is to Matplotlib, for example. So yes, so Plotly is like basically a new generation. It's been around, I think, since 2012 and has already a growing community. But I think there's still limited support for very big data sets. So it might be slow in that regard, but it's good for generating quick insights from your data. So there's also a Dash, which is highly integrated with Plotly. So it's a Python equivalent to Shiny, where you can make apps or dashboards where you can share your data. You can quickly build interactive web dashboards using pure Python. And there's also Dash Bio, which is specialized for the visualization of biological data. So you can visualize 3D molecules, also genomic data, sequencing data, like FASTA files, alignments, chromosome, gene expression, and cell types, microscopy, images, and so on. So you might want to check it out if you have your big Nature paper and you want to also disseminate better your findings. So you can also build your dashboard along with your data. Or say if you have developed a deep learning tool that can predict, then you can also create your dashboards along with your tool. So yeah, in summary, so in the previous webinars, we know that it's very important to be able to effectively visualize and customize our plots depending on our needs, and it's important for scientific storytelling. So there's a wide range of libraries, both in R and Python. So in R, you have ggplot, and in Python, you have also various tools, Plotly, Matplotlib, and Seaborn, and so on. And you also have available libraries for interactive visualizations. So you have basically a rich toolbox that you can use to to select or have good design choices and effectively convey your findings. Yeah, so you can check out the resources that are linked here if you want to learn more. And yeah, thank you.
Yes, so at this point, I would also briefly want to chime in. We put the first couple of resources here that are basically basics on R, because we didn't have time to go over using R Markdown, R Studio, etc. I want to recommend the Modern Statistics for Modern Biology book. A lot of the material from the first part of the talk is directly taken from it. So if you want to look at the code, look at the examples again, highly recommend going there. And then I want to recommend you the idea of Tidy Tuesday. That is an event that's happening on social media. I think it's still on X/Twitter, where these people from R4Data Science publish a new data set every Tuesday. And people on Twitter will basically compete, or maybe not compete, but everyone will publish their own version of the data visualization that they came up with using that data set that was provided. And so if you use their hashtags and you look around the examples, you can learn a lot about data visualization, how other people are doing it. It's not just biologists, it's not just scientists, a lot of journalists out there as well. So you can gather a lot of inspiration for data visualization there. Everyone publishes their code, so you can always go and have a look behind the scenes. Yeah, and both Jian and I wanted to thank a couple of people. So Wolfgang Huber and Susan Holmes are the authors of the book that I was just mentioning, and they kindly provided me with a bunch of slides that we used for this talk. Florian was supposed to originally be giving this webinar with us, but he wasn't able to join, but he did help us in the preparation. And then Julia also was very helpful in getting this webinar together. So we have more time, of course, to answer your questions. I saw that there was a brief discussion in the chat already